Hi everyone, welcome to our 6.1 lesson. This is our first lesson in Unit 3, which looks at linear relationships and graphs of straight lines. We're going to start off today just by looking at some graphs and not doing any real graphing today, but if I look at a graph, interpreting what is going on in the graph. What does a graph tell me? What kind of story is it telling? So that's what we're going to have a look at today. Let's go ahead and get started. So first of all, a graph shows a relationship usually between two different quantities, but a graph is showing a relationship, or it's showing a story, if you like, telling you what's going on for each quantity that is shown on the graph. Graphing data involves plotting one quantity, for example, distance, on the y-axis, and then the other quantity, for example, time, on the x-axis. So on a given graph, we have a y-axis and we have an x-axis. And we can get into graphs that have positive and negative values of y as well. So we can have 4 different quadrants here where we get into some negative values of x on the left-hand side and negative values of y as we come below the x-axis. For now, we're just going to be looking at graphs in the first quadrant, in this one quadrant over here. So let's have a look at an example of one. Let's say that we were to plot distance against time. So imagine if we were looking at a graph of distance over time for somebody, or maybe for a car that's traveling at a constant speed. So if we have distance, we always plot one quantity on one of our axes. So on our y-axis we choose distance, and let's say that's in kilometers. We put our units there. And on the other axis, the x-axis, we're going to plot time. Let's imagine that our time is in minutes here. We always want to show what the units of our quantities are. If we had a table of values, or we were told, for example, that y is equal to x, so for every 1 minute I travel 1 kilometer, okay, I could plot a table of values, x against y. And if I had the following values, if x was equal to 0, that would make y equal to 0. If x was equal to 1, y would be equal to 1, and so on and so on. So x and y are always equal, so whatever value here I'm choosing for x, I'm going to get the same value for y over here. And that would just continue for any value that I picked. If I went ahead and plotted that data, so on my y-axis, if I went up by each division was worth 1. So 1, 2, 3, 4. And my time was worth, each division here was worth 1 as well. So there's 1, 2, 3, 4 minutes. I could plot a data point for every one of my points on the graph. So the point 0, 0 is when x equals 0 and y equals 0, and that's right here at the origin. The next point I will put is for x equals 1. Well, here's x equals 1. There's y equals 1. So I put a point right where those two meet. My next point is going to be when x equals 2 and when y equals 2. So I'm coming to look and find where those meet, and I'll put a point right there. And then the last point I have here is when x is equal to 3, y is equal to 3. So that's going to be right here. At that point, I could connect those with a line, and that's a straight line. This is a linear relationship. And the line is my graph, and it is representing a relationship. It tells me that x and y, distance and time, are related to each other. And as I increase in time, I see that my distance also increases. Let's go ahead and talk a little bit more about interpreting some graphs. When we interpret graphs, the direction of your line and the slope of your line tell us important information. The direction, what I mean by direction is whether a line, and this could even be for a curve as well, but whether that graph is going up or down. So in the example of a line, is that line going uphill or downhill? And the slope has to do with how steep a line or a curve is. So this is the steepness. A straight line, sorry folks, just a sec. Just move this down a little bit for us. Oh. So everybody, somehow I've accidentally got, this is cut off a little bit. Let me just see if I can just move that. No, it doesn't want to move. There we go. Okay, sorry. Okay, so a straight line means a constant rate of change. In other words, the x is changing at a constant rate with y. Okay, constant rate of change. A rate of change is just showing us the change in one variable over the change of another. So it means here that the change in our y quantity, so whatever's plotted on our y-axis, over the change in x is constant. So in other words, if it was distance and time, every minute or every unit of time, y is changing at a constant amount. And so we see a straight line. This is always true. Straight lines tell us that we have a constant rate of change, or in other words, a constant slope. A steeper line indicates a faster rate of change. So the steeper the line, the faster y is changing with x. Let's compare two graphs here and talk a little bit about what information they tell us. So if we look at the graph first here, number 1, this graph on the left, I see I have a red line and I have a green line. I have two lines. And what I see here is that they're both straight lines. So immediately I know that we have a constant change in y with x. Okay, so straight lines. So the change in y over the change in x is constant. Okay. When I see this graph, I see that the red line is steeper than my green line. Imagine that I was walking up a hill on that red line, and I started at the bottom and I was walking up that hill. I can see that the red line would be a lot steeper hill to walk up as compared to the green line. So this is a steeper slope. And a steeper slope means a faster rate of change. So y is changing faster with x on my red line compared to my green line. So my green line is not as steep. So the rate of change is slower. To compare that, if you just pick the same time on the, imagine our x-axis here was time. And for example, let's imagine that our y-axis was distance, just to give some actual values here. So imagine that this was distance and I have time in minutes on my x-axis. If I just picked a time like say 12 minutes, okay, if I came up to my green line at 12 minutes, if I come over here, I can see at 12 minutes that I'm at about, looks like about maybe 8 kilometers. And if I look at where I am on the red line at the same amount of time, so at 12 minutes, if I come up to my red line, I can see that I've traveled 12 kilometers. So I can see that I'm traveling at a faster rate if I'm traveling along the red line compared to the green line. So first of all, this is tells us the difference between the steepness of slopes, so which one's faster. The other thing I can see about this graph, these two lines, is that both of these lines are going in a upwards direction. In other words, they're heading up. And I know that that tells me that my distance is increasing with time. So I have, whenever we have the direction here, is upwards, and that means this is an increasing rate. So it tells me that my distance is increasing with time. Let's come over here and do something similar, a different graph. You have a graph on your notes. It looks like this. On our y-axis, if this is our y-axis here, and our x-axis is down at the bottom, we have two lines, and I'm going to do my best just to sketch them in. They're straight lines, and they look something like this. Okay, something like that. Again, I have two straight lines, so I know that my rate of change is constant. There's a few things that are important about this graph. The first thing I recognize is that these lines are going downhill compared to the graph I looked at before. So on graph number 2, I have my direction is downhill. That tells me that y is decreasing as x increases. So in other words, as I go along the x-axis at the bottom here, every time I go along a unit, I see that I come to a lower and lower and lower value of y. So this is a decreasing direction. My slopes are going down. This is also called a negative slope. I can still compare the steepness of these two lines. If I have a look at the line on the top, imagine if you were skiing down this hill. So I like to imagine that I'm on a pair of skis. Well, which of these two lines is the steepest line? Can you see that it's the bottom line? This is a steeper slope. That means that this is a faster rate of change. In other words, y is changing faster with every unit of x on the bottom line. On the upper top line, this looks like a more gradual hill. This is less steep. So the slope is less steep, which means it's a slower rate of change. In other words, y is changing at a slower rate with x compared to the line below it. So we can interpret a lot of things just from looking at the direction of a graph as well as the steepness of a graph. A horizontal line it tells us something really interesting as well. When we see a horizontal line, that means that there is no change in y with x. So for example, let's just make this our y-axis. This says t down here. It probably is representing time, but let's make it x. And what I'm seeing here is that at any single value of x, so if I were to pick, say, 1, 2, and 3, if I came up to where I am on the graph, I'm always at the exact same place for y. So even as x increases, y stays the same. So as x increases, or I go to higher values of x, y stays the same. In other words, the change in y over the change in x is going to be equal to 0 because I will have 0 on the top. The change in x will be, I could pick 2 points and figure out the change. I could have a number down here, but I'm going to get 0 as my answer because I have 0 on the top here. So the change in y is 0. This tells me that I have no change, and depending on what quantities we see on our y-axis, this could tell us some interesting things. So for example, if I were to Let me just put a quick example here for us. So let's say, for example, that on our y-axis we had distance in kilometers. And let's say on our x-axis we have time in minutes or hours, doesn't matter. What does this straight line tell me? It tells me that as I move along in time, I'm at the exact same distance. So there's no change in y, which means that this, if I was plotting the distance that I'm moving or that an object's moving, this shows me that that object or that person is not moving. They are at the same distance from where they started. So they're not moving. Curved lines are a little bit different than straight lines. Let's go ahead and have a look at a curved line. So curved lines show that the rate of change is not constant. Only straight lines have a constant, what we call a constant slope or a constant rate of change. So the change in y over change in x is staying at the same rate. It's constant. Curved lines show that the rate is either increasing or possibly decreasing. If we have a look at this graph here, if I look at the graph on the left-hand side, it says accelerating. If we were to think about, again, distance here, and I have in kilometers, for example, okay, and I have time on my x-axis, maybe in hours. What I can see here by looking at this, if I was thinking about this, I have, if I'm starting at 0, as I move along in time, I am increasing in my distance. This is increasing in distance. And I see that in the beginning of the graph, if I were looking at the difference in steepness, I can see that at the beginning of the graph, it's a little bit more gradual. So the beginning of the graph is a little bit more gradual. It's a more gradual slope. Or in other words, it's a more gradual increase. And then as I get higher up towards the top of the graph, I can see that this becomes steeper. So again, imagine you're walking up this hill. The steepest part of the hill is at the top. So that tells me that at the top of this graph, I can see that my rate is getting faster. I have a faster rate in the steepest section. At the beginning, the distance that I'm traveling, so if we think about speed here, at the beginning, I'm increasing in distance with time, but it's at a pretty slow rate. And then all of a sudden, I start to increase at a faster rate. So I start to cover more distance in less time because it's a little bit steeper. So this would be an example of speeding up. If I look at the opposite graph where I have, again, it's still increasing. I see that I have a curve that's going in upwards direction. But if I compare the difference in the steepnesses here, if you imagine you're walking up this hill, the beginning of this hill, so from about here to here, is the steepest part, which tells me that I have the fastest rate in the beginning of this graph. So again, if this was me driving, I'm covering distance very, very quickly. And if this is time on the bottom, I'm covering distance very, very quickly in the beginning. And then after a certain period of time, I see that my hill or my curve starts to become more gradual. I'm still covering distance. I'm still increasing my distance with time, but it's at a bit of a slower rate. So I'm starting to slow down a little bit here at the end of this graph. We can sum this up down below at the bottom as well. So it says, for the first graph, as time increases, the increase in d, in distance, is gradual at the beginning. Then the increase in d becomes much greater or faster. On the other graph, as time increases, in the beginning, the distance is still increasing, but it's quite quick at the beginning. So I see that we have, we're covering distance very, very quickly at the beginning. It's a steeper rate. And then as d, and then the increase in distance slows towards the end of the graph. So the steepest part of a curve, or a line always has the same steepness all the way throughout it if it's a straight line, but a curve, if I'm looking at a curve, the steepest part tells us that that's where we have the fastest rate of change. So y is changing with x at a fast rate. Let's have a look and now put some of this knowledge to use and do our own, follow a graph where we have some changes in from curves to straight lines to horizontal lines. So let's look at the next example in our notes. So we here asks us to describe each section of the graph, and we have to use the following choices. So either a constant increase or a constant decrease. And if you think about that, if it's going to be constant, that means it's going to be a straight line. Okay. An increase or decrease that is not constant, well, that will be a curve. So a non-linear, non-straight line. No change will be a horizontal line. Okay, so we have quantity B plotted against quantity A, and let's have a look at what's going on. So for the first section, from A to B, I see that I have a straight line. This is straight. And that tells me that it is a constant rate. So I'm decreasing at a constant rate. Let's also write that down. So this is also decreasing. So if I go ahead and I think about what's going on here, let's go ahead and plot this over to the side. So from A to B, we have a constant increase or decrease. Well, look at the graph. We're going downhill, so quantity B is decreasing with quantity A. Okay, so constant decrease. Okay, let's look at from B to C. Well, if I look at B to C, on my graph, it's a horizontal line. This is a horizontal line. Horizontal line tells me there's no change. So quantity B is staying the same. So no change. Let's look at section C to section D on our graph. Well, from C to D, we're going down a curve. So this is not straight, this is a curve. And it's decreasing because it's going down. So from C to D, I can say that this is decreasing. Quantity B is decreasing, and it's at a not constant rate. So if I have a look at that, I see that it looks like the steepest part of this graph is right at the beginning. So at first, quantity B is decreasing quickly, and then it starts to slow down a little bit as we get to the bottom of the curve. Let's look at from D to E. We're coming back up a curve now. So again, this time, same idea. We have a curve, but this is an increasing curve. I see that I'm going uphill. So quantity B is increasing with quantity A. But again, it's not constant. So this time we have an increasing rate, or I should say quantity A is quantity B is increasing, and it's not a constant rate. In fact, if I look at it, it looks like the steepest part of that curve is at the top, and so that rate is increasing or accelerating as I go up the curve. Let's look at E to F. From E to F, I have a straight line. Straight lines tell me that the change in quantity B with quantity A is constant rate of change, and again it's decreasing because it's going downhill. So if I describe that, it will be a decreasing and constant. So decreasing change with quantity B at a constant rate. And finally, the very last section here is from F to G, and this time we have a straight line again, but this time it's increasing. So our straight line, and it's going uphill, so it's an increase in quantity B. So as we go along the x-axis, or quantity A is increasing, quantity B is increasing as well. So this is going to be increasing and constant. So it's increasing at a constant rate. You're going to be asked to do some questions like this in your worksheet, and so you can always come back to this example to help you out a little bit. Let's look at some real examples then, matching situations to graphs. On your next page, you have to choose an appropriate graph for some different situations. We have to use a little bit of common sense here. So let's look at the first one. Number 1 here says, which graph matches the temperature of a cup of coffee over time? All right. Well, think a little bit about a cup of coffee, right? Your coffee starts out hot. So if we were here, we would be plotting temperature on the y-axis versus time on the x-axis. Okay, so your coffee would start hot or start at a high temperature. So it would start off high on the y-axis. Then it would gradually cool. So let's say high on the y-axis, and then it cools gradually. So that means it's going to be decreasing. I'm going to expect to have a graph that's going downhill because temperature is going to be decreasing. So we are going to see a decreasing temp. And again, I'm assuming that my coffee is not going to cool at a constant rate, 1 degree every single minute. It probably is going to cool sort of quickly and then sort of stay at a constant temperature for a while and then eventually get very cold. So I would expect to have a curve here because I don't think that this will be a constant rate of change. So which of these graphs matches that? Well, it's not going to be graph A because graph A starts off very low on the y-axis. There's my y-axis, there's my x-axis for all of these graphs. So that means that I have really only one choice. There's only one graph that starts off high on the y-axis, and it's this one right here, graph C. And then I see that I have a curve, and it's a decreasing curve. So that tells me that if I had temperature on the y-axis, temperature would be coming down over time. So my answer is going to be C. So graph C will be my answer for number 1. Let's have a look at another one. Which graph matches a car accelerating to a constant speed? Okay, the first thing that I see here is constant speed. Okay, so that's going to be a straight line for sure. Let's think about what we would be plotting if we were going to be graphing a car traveling at a constant speed. Well, if we were going to be graphing this, again, we probably would have time on our x-axis, and on our y-axis, we would be plotting, let's see, probably speed versus time. So speed would be on our y-axis and time would be on our x-axis. So let's think about what we would expect. Well, if it was the car was accelerating at the beginning, I would expect to have a line that is increasing because speed is increasing with time. Then when the car is traveling at a constant speed, in other words, its speed is not changing, so then no change in speed, I would expect to have a horizontal line. Okay, so let's look at our graph up top. Definitely it's not going to be A, because A, I see that I would be increasing in my speed, but then I'd be decreasing in my speed. Graph B looks pretty good, because here I could see that I would be, if this was speed versus time, I would be increasing in speed, and then I would stop and I would be at a constant speed for the rest of the time. So graph B definitely matches. Graph C does not match because, again, we're coming downhill. And graph D could work for us, except for the part of our problem that says we are going to eventually reach a constant speed. And so D is not going to work for us there. So our answer for this is B, graph B. Number 3 says, which graph matches the height of a soccer ball kicked in the air? Well, we would be plotting height versus time, and height would be on our y-axis, time would be on our x-axis. And so what would we expect? Well, at the beginning, the soccer ball would be on the ground. Okay, so at the beginning, so at first, the height would be 0. Then, after we kick the ball, it would be in the air, so the height would be increasing. So then h would increase. And then it would reach a maximum height. And then it would come down. So I would see h would be decreasing. So then h would decrease. So which of the graphs match that? Looks like A. I would start it, if this was my height and this was my time, so height versus time, I would start off on the ground and then I would kick the ball, it would come up in the air, reach a maximum height, and then come on back down again. So graph letter A matches number 3. Finally, which graph matches the distance a person walks during a hike? I'm going to add to this at a constant speed, just to make this a little bit more clear. So imagine if we were to graph the distance against time. So we would be plotting distance versus time. Time is on our x-axis, distance would be on our y-axis. And what would we expect? Well, at first, our distance would be equal to 0 at time 0, because they haven't gone anywhere yet. But as they start hiking, as time increases, so as time increases, so as x increases, I would expect that the distance would increase. So I'm looking for an increasing graph, and if it's at a constant speed, in other words, distance is changing at a constant speed with time, then I would expect to have a straight line. So a straight line going in positive direction. And that would leave me with D. Graph D represents a person hiking, moving further and further and further away over time at a constant rate of change. So graph D matches number 4. In your notes, we have sketching an appropriate graph representing a person's height as the person ages. I'm going to go ahead and skip this just for the sake of time today, and let's do another example here. So we're going to move on to the next example on the last page, and it says sketch a situation. Okay, so Jim leaves his home and walks to the store 2 kilometers from home. Then he slowly jogs to his friend's house 4 kilometers from home. He visits with his friend for a while and then runs home, slowing down a little towards the end of the run. So we're going to go ahead and plot this on our graph. So let's think about what we're plotting. Well, we're going to be showing how Jim is changing in distance over time. So let's put distance in kilometers on our y-axis. And on our x-axis, let's put time. And let's look at what it says. It's talking about, we don't actually have any values for time. So we could say this could be minutes. And I think on your graph it has minutes there. Okay. So let's go ahead and say this is distance from home here. So we're starting off at home. So at 0, this is home. Okay, and so let's break this into some different parts. So the first part is that Jim leaves his home and he walks to the store. So he leaves his home and he walks to the store. The store is 2 kilometers from his home. So the distance that he's going to travel over here on my y-axis is going to be 2 kilometers. So there's 1 kilometer, there's 2 kilometers right there. And we're going to assume that it takes him a certain amount of time to get to the store. Okay, so we can have some divisions along our time axis. Here we don't actually have any values, but that's okay. Okay, well, let's say that he's going to walk at a constant rate to the store, because usually when you walk, you're walking pretty much at a constant rate. So he's going to travel, let's say it takes him to here. Okay, he's going to travel all the way up to 2 kilometers, and he started at 0. So we have a straight line here up to 2 kilometers. So that's Jim going to the store. And we'll say here he's walking. So it's not a really fast rate. Okay. So maybe it took him, I don't know, 20 minutes, whatever the time is along the bottom. Then he slowly jogs to his friend's house, which is 4 kilometers from his home. So he's going to go, he's 2 kilometers from his home right now. He's going to now jog to his friend's house, which is 4 kilometers from his home. Okay, so here's 2 kilometers is the store. This is his friend's house. And let's think about what kind of a line that is going to look like. Well, if he's jogging, it's going to be a little bit steeper line than the walking line, the red line that we just drew. So let's imagine that it takes him half the amount of time if he's jogging to cover 2 kilometers. So we're going to come all the way up. He's going to come up to 4 kilometers. But let's imagine that it takes him not as much time this time. So all I'm going to show here is a steeper line. Okay, straight line, because we're assuming he's jogging at a constant speed here, but this is going to be, he's now jogging. So it's going to be a bit steeper. Okay. He visits with his friend for a while. That's important. He visits with his friend for a while. So for a period of time, he's not moving. Let's imagine that he visits for, let's say, if each one of these divisions are 20 minutes, let's say he, 20, 40, an hour, let's say. So let's move ahead, 3 divisions. I'm going to draw a horizontal line for a period of time. And that horizontal line tells me that he is not moving. So he's staying at the same distance. He's at his friend's house, 4 kilometers from home, and he's not moving for a period of time. So this is when he's visiting. Okay, finally it says, then he jogs home, or sorry, he runs home, slowing down a little bit towards the end of the run. So he's going to run home. So I'm going to have a decreasing line coming down to 0 again because he's going to return home. It tells me that he's running, so it's going to be steep, but it's also going to be, he's going to slow down a little towards the end. So I'm going to have a decreasing, okay, only because he's heading home. And I'm going to have a curve because his speed is changing. So if I draw my curve, I want my curve to be steepest at the beginning, and then it's going to get more gradual towards the end. So I'm going to have a curve that's pretty steep, and then it's going to become a little bit more gradual. And there, at some period of time, he gets home again. So this is him. This is him running home fast at first, then he slows down. So if we were given this graph, we could have interpreted what he was doing, but we can also go from a situation and sketch ourselves a graph as well. That's it for this lesson. I'd like you to try yourself interpreting some graphs in your 6.1 questions. Thanks for joining me. I know this was a bit of a long lesson. Good luck, and we'll see you next class. Bye for now.